Hi, I'm Saanvi chaparala, and today we're going to be learning about triangle congruence postulates. So what are we going to be covering? In this video, we're going to first learn about important vocabulary and signs. Then we're going to learn what are the 5 triangle congruence postulates, and we're going to use them in practice problems. So let's get started with vocabulary. The first word we need to know is congruence. In math, it signifies that two geometric shapes are the same size and shape. And the symbol we use to represent this is over here. In this video, I'm going to be saying congruent a lot, so it's good to know what it means. Postulate. It is a fundamental statement that is accepted as true without proof. SSS, SAS, ASA, AAS, and HL have been proved that they can accurately prove triangle congruency, making them fundamental statements that are postulates. Signs. Throughout my examples, and we're going to be seeing the dashes and small curves on triangles. The dashes represent that segments are congruent to corresponding segments, meaning that AB is congruent to ED. We know this because it has one dash mark. Same as how AC is congruent to DF, since it has 2 dash marks. This is the same for angles. In this example, angle B has 1 angle mark, so it is congruent to angle E, which also has 1 angle mark. So, now we're going to learn about the triangle congruence postulates, all 5 of them. And we're going to learn how to identify them on triangles. The first one we're going to learn about is side, 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 or SSS. We can identify this in triangles if we see 3 corresponding congruent sides, represented by the dash marks. Now let's learn how it works, or why it works. For example, let's say we have 3 line segments. One of them is 6 centimeters, other one is 4 centimeters, and the last one is 5 centimeters. If we use these 3 segments to create a triangle, we're only going to be able to create one triangle. No matter how hard we try, if all the segments line up with each other, they will only form one triangle, meaning that if 2 triangles have the same corresponding congruent sides, they are basically the same triangle, meaning that they are congruent. Though SSS is the triangle congruence postulate, AAA, or angle, 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 does not exist. Therefore, let's take example in these 2 triangles. We can see that they have 3 corresponding congruent angles. But they are still not congruent because AAA is not an existing triangle congruency postulate. Why? As you can see in this example, this triangle is much smaller than this triangle, but the angles are still congruent. In a triangle, it can have congruent angles but can be different sizes, meaning that it's not congruent because the line segments are not the same size, but it is similar. The next one we're going to be learning about is side angle side, or SAS. This is shown by one congruent side, one congruent angle, and another congruent side. So how does it work? Say we're given a triangle with a proof showing that it follows SAS triangle congruence postulate. The reason it works is because since we know that these are congruent in both triangles, then the distance from this point to this point can only be one segment. Meaning that if 2 triangles follow the same and have both congruent segments and a congruent angle, there's only one possible way to finish off the triangle, meaning that both triangles are congruent by the SAS theory. Because therefore, after finishing it off, they will become congruent triangles since they have congruent angles and the last congruent side. These two triangles are not an example of SAS because the angle is not in between both sides. This is a common misconception, but this is not an example of SAS. Next is angle side angle, or ASA. This is shown by one corresponding congruent angle, a corresponding congruent segment, and another corresponding congruent angle. Say we have two triangles that show or have these proofs. If we were to draw the rest of the triangle, there's only going to be one possible way to finish them off. No matter how long we draw the segments or how short, if they were to intersect, they would intersect at the same point for both triangles, proving that they're the same triangles. Angle side, or AAS. This is shown by two corresponding congruent angles and one corresponding congruent side. How it works. Say we have a triangle with this proof. If we were to fill in the last line segment to finish the triangle, there's only one possible line segment we can use. Same as before, no matter how long or how short, if it were to use the proof that we were given before of the angle measurement, then there's only one possible way it can connect. In this example, we are not using the angle measurement, therefore that's why it cannot connect. Hypotenuse leg, or HL. This theory only applies to right angle triangles. This is shown by one corresponding congruent leg of the triangle, and the hypotenuse of both triangles are congruent. And of course, it's a right angle, so it has a 90-degree angle. So we have a triangle with these proofs. If we use the Pythagorean theorem, we can figure out the last side. And the last side will be the same for both triangles, since the other two sides are congruent. So let's use these theories in practice problems. Okay, our first problem is asking, are these two triangles congruent? And if they are, by which triangle congruence postulate? I do not include hypotenuse leg in these triangle congruency problems since it only applies to right angle triangles. In this example, we have two triangles, triangle ABC and triangle DEF. We can see that they have one corresponding congruent side, then a corresponding congruent angle, then another corresponding congruent side, proving that they are congruent by the SAS triangle congruency postulate. In our next example, we have different triangles. These two triangles have three corresponding congruent sides, meaning that they are congruent by the SSS, or side-side-side congruence postulate. This is our last one. These two triangles look congruent, but they are not, because they have three corresponding congruent angles. This is not enough information for us to decide that these two are congruent, because we know that angle is not a real triangle congruency, as said here. So thank you for listening to me explain triangle congruency postulates. Hopefully you have learned a few things from this video. Thank you.